Hello, everyone. The title today is Chemical Bond with emphasis on ionic bonding. Chemical bond with emphasis on ionic bonding. Before we continue, let's do a little review of periodic table. We did look at, in the previous videos, at the periodic table and said that every element in the periodic table is neutral, and all the elements except the noble gases are unstable. So the noble gases is this group 18 or 8A. This group is the only group that is stable. Every other group is not stable. Every other group is not stable. Then we also looked at can we say that an atom is stable? When is an atom stable? More review. So looking at all of this, can we identify the atoms that are stable? Looking at these images, and also this electron configuration and abbreviated electron configuration. Pause the video and try to understand, try to answer this question. Identify the ones that are stable and state why. Pause the video. This is supposed to be lowercase s. I'm sorry about that, lowercase s, okay? Pause the video. Hopefully, we did it right, but let's do it together. Okay. We first of all have to understand, when do we say an atom is stable? An atom is stable when it has maximum number of valence electrons. If an atom has only one energy level, which means the atom must be in period 1, the maximum it can have to be stable is 2. But if an atom has 2 or more energy levels, it must have 8 to be stable. That's the maximum it can have. So all the elements in group 18 or 8A have maximum number of valence electrons. Therefore, that's why they're stable. Every other element does not. So let's look at, is this stable? We have to understand again what energy valence electron is. So this is first energy level, second energy level. Then this is third energy level. So this has 2 valence electrons, so that's not stable. Then this one, abbreviated electron configuration. This one has third energy level, so 2 plus 6, 8. Okay. This has total of 3 energy levels, so it must have 8 valence electrons to be stable. So this is stable. This is stable. Then what about this one? This one is Bohr model. So we look at the outermost energy level. If it has 2 or more energy levels, this one has 2. So the atoms have to have 8 to be stable. So this is stable. Okay. What about this one? This has 3 energy levels. It should have 8 to be stable. So this is not stable. It has only 3. This one, it's the same thing as this. I don't know why I have to do the same thing there. Then this one, there's 3 energy levels. So 1, 2, 3, 4, 5, 6. So it's not stable. It has only 6. Then this one has only 1 energy level. It has 2, so it is stable. Okay, hopefully you got it right. Hopefully you got it right. So when atoms are not stable, they're miserable. They want to be stable. And they want to be like noble gases. They want to be stable because they want to be like noble gases. Okay, how can they become stable? For them to be stable, they have to combine with other atoms. Let me just give you an idea of what I mean. Each of these, none of these is noble gas. Therefore, each of them is unstable. for this to be stable, they have to combine to form a compound. For example, this will combine with this will combine with this. Okay, let's see what will happen. You see this? This is stable now. Okay, it is stable. You see that? This, there's something connecting this atom and this atom. There's something connecting this atom and this atom also. Okay, so this is now stable. Each of these atoms is stable because they combine with another atom to be like noble gas. Okay, so let's look at another one. Let's see. I get this one. So let's say I have this. I have this. They're all separate atoms. Then I combine them. You see that? This is stable. Each of these atoms is non-stable. Alone, they're not stable. You see what is holding them together? You see this? Bond is called bond, holding the atoms together. Okay? So that's how they become stable. But there's more to it we are going to discuss. So atoms of different elements can join together to form entirely different substances called compounds. So what causes them to stick together? You saw one of them, like you saw the bond holding them together. Okay, that's one type, one way of them joining together. These ones, like you saw in the simulation, that's how they become stable, by joining, forming that chemical bond that is holding them together. So what is chemical bond? A force that holds two or more atoms together makes them function as a unit. After all, you saw how you have individual atoms, they bond together and they form a unit. But one thing you must know is when they bond together, there are different ways which I will explain. Different ways they bond together. It's not only one way. And when they bond together, each of the atoms becomes stable. Okay? So you saw clearly how different atoms bond and they form like a unit. It's a force. That chemical bond is like a force holding the atoms together. So the reason the atoms bond together, say, why do atoms form chemical bond? The reason is because they want to be like noble gases. They want to be stable. They want to have maximum number of valence electrons. That's why they form that chemical bond. That's why they bond with each other. There are different ways they form this chemical bond. It can be by sharing of electron. It can be, we call it by its covalent bond or metallic bond. A covalent bond, when you have them sharing non-metal sharing electron with non-metal, or metal sharing electron with metal. Okay. Then another way is by transfer of electrons, which is what we focus on this particular video. We focus on how the chemical bond called ionic bond, which is between metals and non-metals. Okay. Before we continue, let's watch this funny video.
Welcome to Dogs Teaching Chemistry. Our first lesson is chemical bonding. Chemical bonds are what holds atoms together. A chemical bond is an attraction between atoms that allows the formation of a chemical substance. The electrons that participate in a chemical bond are called valence electrons. These are electrons that are found in an atom's outermost shell. Let's take a look at the types of chemical bonds that can be formed between atoms. An ionic bond is formed when one of the atoms will lose its electron to the other atom. This results in a positively charged ion, called a cation, and a negatively charged ion, called an anion. Positive and negative attract, and the result is an ionic bond. Covalent chemical bonds involve the sharing of a pair of valence electrons by two atoms. There is also what is called polar covalent bonds. These are covalent bonds in which the sharing of the electron pair is unequal. The result is a bond where the electron pair is displaced toward the more electronegative atom.
So there are three types of chemical bonds: ionic bonds, covalent bonds, and metallic bonds. And today we focus on ionic bonding. Okay. Okay, ionic bond is forms between metal and non-metal. As you know, sodium is metal and chlorine is non-metal. Okay. And what happens here is we look at the valence electron here. Sodium has only one valence electron. Okay. And remember, when the valence electron is less than 4, if you watch the video on, I think, cations and anions, if it's less than 4, then it will lose all of its valence electron. If the valence electron is greater than 4, it will gain a valence electron enough to be octet, okay, or duplet, depending on the valence electron. So this one has 7 valence electrons, so it will need 1 to be stable. So both of these are not stable, and each of them is miserable. Each of them wants to be stable. So I'll show you how they become stable. It will start by sodium losing its electron to chlorine, and this will now become a cation. This will be an anion. And then positive and negative will attract to form a compound called sodium chloride, which is the table salt we use at home. So that's how ionic bond is formed. So I want you to watch this simulation as to how it happens. You see that? Now, this is what is formed. This is the name of the compound formed, sodium chloride. This will attract, and you find that the charges are equal. That's 1 plus, 1 minus. Okay? Let's look at another one. Let's look at this one. Okay? This has 2 valence electrons. This has 6. Okay? Think about how do you think it will be stable. You can pause the video and think about it before I explain it. Okay, now, you see that? Now this has 2 plus, 2 minus. They will attract and form MgO. That's the compound they will form. Okay, what about this one? Okay, pause the video. Pause the video. Look at that. Now, what I haven't emphasized, this had 7, now it has 8. This is stable. This is now 8 is stable. This is now 8 is stable. There are 2 chloride ions and 1 magnesium. So what did it, this one, we started with chlorine and it's negative, it's an anion, a negative ion. So the name will change. Instead of chlorine, it will be chloride. So now this one looks like argon. This one looks like neon. Look at, if neon looks like this one also looks like argon. Now want to be like noble gas. They are not really noble gas, but they are trying to be like it because now they are stable. And when we draw Bohr model of noble gas, it will look exactly like this. Okay. So what is ionic bonding? We saw it in the simulation. So it's a chemical bond formed through the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. It is between metals and non-metals, or metals and polyatomic ions. We come to this in another video, what polyatomic ion is. So ionic bond is the force of attraction that holds together oppositely charged atoms. Okay. So example is like table salt contains ionic bond. You saw sodium chloride, sodium and chlorine, they bond together. That's this common salt we use. So example of a compound which contains ionic bond is sodium chloride, or all of the examples you saw so far. Okay. So formation of ionic bond, it requires the presence of two or more metals. You have two metals, two elements, I mean. You have a metal that can donate electron, a non-metal that can accept electrons. The electron lost by the metal is what is gained by the non-metal. Okay. There are other ways we can represent how this chemical bond is formed. We can use Lewis dot structure to represent it. Lewis dot structure is a way to represent valence electron of an atom using element symbols surrounded by dots. I think I will show you how to draw this. The way I talk about it will not make sense, but I'll show you how to draw it. So when you draw the symbol of that element, and then you figure out the number of valence electrons, and you use dots to put around it. So I will show you how to do that. So let's draw Lewis dot structure. Let's say I want to draw Lewis dot structure of calcium. Okay. The first thing I do is to write a symbol of calcium, and then I'll figure out the number of valence electrons. So you look in your periodic table. Instead of drawing a Bohr model or writing electron configuration or abbreviated electron configuration to figure out the number of valence electrons, you can always look at that, the main group elements that tells you the valence electron. So calcium is in group 2A. So it has two valence electrons. So what I will do, I'll put one electron here, one electron here. So that's the Lewis dot structure. If you do this, it's also correct. You start from here, you go here, that's correct. If you do this, you can start from here, that's also correct. But if you do this, that's not correct. Okay? When you place, do electron, you do this Lewis dot structure, you have to put 1, 1, 1 on each side. You imagine 4 sides. Let me do sodium, for example. Sodium, you imagine 4 like square. That will be your imagination. Okay. I can start from here. 7 valence electrons. I put 1, 2, 3, 4, 5, 6. Oh, I'm sorry. Sodium has 1 valence electron. What am I doing? It's only 1. What I had in mind is to show you sodium has only 1 valence. Sorry about that. But I'm thinking about showing you chlorine. Chlorine has 7 valence electrons. So you imagine 4 sides. 1, 2, 3, 4, 5, 6, 7. Okay. You can also do it the other way. You can also do 1, 2, 3, 4, 5, 6, 7. That's Lewis-Dot structure for chlorine. Then what if I want to do Lewis-Dot structure for carbon? Carbon has 4 valence electrons. It will be 1, 2, 3, 4. Okay? If I do this, 1, 2, 3, 4, that's wrong. Okay? That's totally wrong. You have to place 1 on each side before you double it. Okay? So that's how to write the Lewis-Dot structure. I want you to pause the video and draw the Lewis-Dot structure for these 3 elements. Pause the video. Hopefully, you got it right. Remember, this one, you can start, you don't have to start at one place. As long as you have 2 paired and 2 unpaired, that's fine, okay? So if you pair this one up also here, that's not right. So that's the Lewis-Dot structure. Now we show how chemical bond is formed using Lewis-Dot structure instead of the bond model we saw, because that's another way of showing how chemical bond is formed. I want you to look at more examples of Lewis-Dot structure. Look at that. Look at it. Okay. Look at helium. Because it's stable, that's why you have these two together. Okay. Take notes, compare this to others, you find that this is stable. They have maximum. This has maximum because it has only one energy level. It needs only 2 to be stable. I want you to see example of when we lose Lewis-Dot structure to see how chemical bond is formed. Look at this. Sodium has only 1 valence electron. Chlorine has 7. You have this one gets transferred to this. Now we represent it with this. You see that? Square, 1 plus, 1 negative. This is non-stable. This is non-stable. We end up like this. That's what is formed. Okay? That's an example of how Lewis-Dot structure can be used to show chemical bond. So between sodium and chlorine, there's chemical ionic bond formed. There's attraction between plus and negative here. They attract each other. That's how this will be neutral compound. It cannot be charged. Why is it neutral? Because the charges here are equal, 1 plus 1 minus. Okay. If not, they cannot attract and form a neutral compound. That's very important. Another example of this is this. Between calcium and chlorine, you see that? You see calcium gives 1 to this chlorine, then this one gives to this one. We end up then 2 plus, that's 1 minus together, there'll be 2 minus. Then we end up, there's 1 calcium and 2 chloride ion. This is telling us the number of atoms. There are 2 atoms of chloride ion. So that's how we get that. For better understanding, let me show you what is going on here. Let's choose what we've done before. Sodium, chlorine. Notice metals are on the left side of the staircase. Non-metals on the right side of the staircase, right? There's 1 unpaired here. There's 1 unpaired here. Okay. This one is not stable. This one is not stable. So this gives transfers its only valence electron to here. This now becomes stable, right? Now, so because this is metal and non-metal, it will form ionic bond. Then it's asking you, how many sodium and chlorine atoms will you need? Okay, we need only 1 of each. So 1 sodium, 1 chlorine. Look at that. Then that's what we saw. Then you end up like this. Okay, let's do another example. Let's go to magnesium, oxygen. Okay. There are 2 unpaired here. There's 2 unpaired here. This needs to lose 2 to be stable. This needs to gain 2 to be stable. So this is metal, non-metal. So it will form ionic bond. So now, how many magnesium will we need? How many oxygen do we need? We need 1 of each. So 1 of this, 1 of this. Look at that. Okay, this should be 2 plus 2 negative, okay? Then this is there's 1 of this, 1 of this. That's how we end up like this. Remember, you have to put this in parentheses, put the charge, because it lost 2. That's 2 plus, because it gained 2 minus, okay? It's supposed to be minus number before this thing. This simulation didn't get it right. Then we do more example. Let's say I have sodium here, and I have sulfur here. Okay. What type of bond will they form? After what, the only thing we are doing now is ionic bond, okay? Now, ionic bond. Now, how many sodium and how many sulfur? Think about this. How many for sulfur? If we transfer 1 of these to here, will sulfur be stable? No. So we will need another sodium. So we will have 2 unpaired. So what we have, we know is ionic. We start with that. Then how many sodium? For this to be stable, and for this to be stable, this has 2 unpaired. This has only 1. So how will it get? The reaction is only between sodium and sulfur. So we need 2 of this for this to get 2 it needs. So we will say it will need 2 sodium and 1 sulfur. 2 sodium and 1 sulfur. So look at that. You see that? Each of the sodium loses 1. 1 plus 1 plus 2 minus. So you end up with this because there are 2 sodium atoms. There's 1 sulfur. Okay. Let me continue to do, because some of you may be confused, to make sure you get it. So what about if I do potassium and nitrogen? Okay. So it's ionic. So now, how many potassium and how many nitrogen? Pause the video and figure it out. If you really did some thinking, this has 3. So it will need 3 potassium. Okay? So it will need 3 and 1 nitrogen. You see that? You see that? The charges have to be equal. 1, 2, 3. Then 3. So there's 3 of this and 1 of this. That's how we get it. Let me do one more. One more. If you didn't get the other one right, hopefully you get this one. Calcium, sulfur. Okay. It's ionic. How many of each do we need? We will need, there's 2 unpaired here, there's 2 unpaired here. So we need 1 of each. See that? You see that 1 of this, the charges are equal. 2 plus 2 minus. Please don't write it like this. It has to be the number before the charge. Okay. Let me do one more. If you don't get this right, then it means you didn't understand it, because I've done quite a good example. I have this and this. Okay. Try to get this one right. Okay, we know it's ionic because there's metal, there's transfer of electron between metal and non-metal. So looking at this, how many sodium atoms will you need for oxygen to be stable? Okay. If you answered 2 and 1, you're correct. You see that? So you end up with Na, that's 2 of this, and then 1 of this. You see? You have 1 plus 1 plus 2 plus 2 minus the equal, it has to be equal charges. So I want you to do this example. I want you to do this example. Pause the video. When you do this, make sure you show all your steps, okay? You show all the steps, like here. You have to, you see here, you have to, after it's gain is lost, you have to show 2 plus, you have to show this, you have to show this, then the right. I want you to do it, show your work like this, okay? Sodium and oxygen, let me repeat that. Just check if you got it right, sodium and oxygen, okay? It's ionic bond. How many sodium and how many oxygen? You will need 2 sodium and 1 oxygen, okay? Hopefully you got that right. Your formula, you will get this and your formula will look like this, okay? Then aluminum and nitrogen. Let's do aluminum and nitrogen with aluminum, nitrogen. Then we have it's ionic, aluminum and nitrogen. Okay, look at this. There's 3 unpaired here, there's 3 unpaired. Because of that is B11. One of this, just like that. You see that? So you get this should be your answer. Then magnesium and sulfur. Magnesium and sulfur. There are 2 unpaired here, there are 2 unpaired here. It's ionic. If there are 2 unpaired here and 2 unpaired here, it needs 1, 1, 1, 1. You end up like this. Very easy, very easy. Okay. This is a review of what we already know. You want to, what we do next, you need to use this information. So you can take, if you don't have it, you can take a picture of it. All you have to do, because we are going to write formula, okay, without going through those steps, you know, the shortcut method, we call it crisscross method of writing ionic chemical formula for ions, ionic compounds. So what you do is to notice that every element in group 1A has plus 1 charge. Every element in 2A has plus 2 charge. Every element in 3A has plus 3 charge. Then every element in 7A has minus 1 charge. Noble gases has 0. Why? Because they are so happy they don't need any element to be stable. They're already stable. Okay. Now, everything we've done, we've seen the process using Bohr model, using the Lewis dot structure. Now, we can write formula. We can do it in less than 1 minute. Okay, without going through what we did before. Okay, all we have to do, look at this. If I write, for you to write a chemical formula between calcium and nitrogen, like we did before, using Lewis dot structure, or we did using Bohr model where we saw how electrons get transferred. We can bypass that, showing how the electron is transferred, and get to the formula straight. So the first thing you do, you write the cation of this. What is the cation of calcium? You go here, calcium is plus 2. Therefore, it will be calcium 2 plus. Then, what is the anion of nitrogen? You go here, nitrogen, -3. Therefore, it is N3 minus. Remember, when it becomes an anion, the name changes. Okay, the name changes. I will show you that later on. Now, so you have calcium and nitrogen. Okay, this charge is 2 plus, this one is 3 minus, which means they cannot attract each other because the charges have to be equal. So we have what we call the crisscross method of making them equal. So what you do is you take these 3, put it as subscript of calcium, take the 2 and put it as subscript of nitrogen. Then you end up with this. You end up, because you see this 3 that is here, you see that? You see this 2 that is here, that's it. Then you end up with this. Now, what does this mean? It means there's 3 of 2 plus 2. You see that the charges are now equal. So we call this crisscross method. It's so easy. You can do it in less than 1 minute. But now you understood how we got there, because we're starting from the cations and anions. We didn't show how the electrons got transferred. So you already know what happened. You know the chemistry of everything. You just want to get the formula. Okay, know the compound that is formed when they combine. Then we go to another example. Lithium and oxygen. Lithium has 1 plus charges in group 1A. Oxygen is in group 6A, so it's 2 minus charge. So you see this 2 comes here. This 1, we don't normally in chemistry, we don't write it. We end up with this. Okay, which means there's 2 of these cations and there's 1 of this. Okay, very, very easy. Okay, we call it crisscross method. If I ask you to write chemical formula of sodium chloride, this time I didn't say this or this. All you have to do, you look up, as we did before in that main group elements with charges, look up sodium is 1 plus charge. You look up chlorine, because this chloride, when it becomes an anion, now because it's combined, it's an anion, it's IDE, right? So let's see. I want to make sure you understand it. Okay. This example, sodium chloride, sodium, we can get the symbol from periodic table, right? And we know the charge is in group 1A, and then chloride, you come here, chloride is this. So this is the symbol for chloride. Sodium is always the same, cations are always the same as in the periodic table. Sodium, you write the symbol of sodium, you write the chloride, okay? So sodium chloride. Then potassium, so NaCl. 1 plus, 1 minus, and then potassium sulfide. Potassium sulfide. Potassium is in group 1A. Sulfide, you look it up here. You see that? Okay. Okay. So this is the example. Okay. Examples, we look at sodium chloride. Sodium chloride. I showed you how to get the chloride. The charges are equal, so you don't need to do crisscross. So they attract each other, you get this compound. Okay. Then potassium 1 plus, sulfur 2 minus. You do crisscross because the 1 plus, they're not equal. You put this here, then you get this. Then this is what this means. What if we have something like this? Magnesium oxide, I have this, okay? If you do this, it's supposed to be just that. The charges are equal. If you do this, it's totally wrong. I mark it wrong because it means you do not understand why we do the crisscross. You do the crisscross only when the charges are not equal. Okay? You want to make the charges. Okay. Do these practice questions. Show your work as I showed in the example. Okay, I gave only the answers, but pause the video and do these practice questions. You are writing the formula. Okay, show your work. Pause the video. These are the answers. Okay, but I still be proper if you showed how you got to the answer, because you can Google the answer and that doesn't show that you understood it. Hopefully this makes sense. Thank you for watching.